Ya voy a empezar a grabar. All right, guys. So we're gonna begin with this exercise today. We're gonna do number 71, and it is as follows: 8 elevated to the negative x plus 14 equals to 16 elevated to the x, right? So the idea here is to, again, isolate the x, right? That is the idea. We want to find the value for which x has to be replaced in order for the left to be, the left to be equal to the right. All right. So how do we do that? We're going to take advantage of what we know. We know a couple of things about these values, 8 and 16, about these two values, right? I'm going to write it here. What I know. All right, so I know that a elevated to the, 8 is the same as 2 elevated to the third power, right? 2 to the 3. And we're going to use that to change the value 8. I also know that 16 is the same as 2 to the fourth power. All right, look, if I do this change like this, what is going to happen is that here, instead of a base of 8, I am going to have a base of 2. And here, instead of a base of 16, I'm going to have a base of 2 as well. Meaning, now the bases are the same and we can cancel the bases. That's the idea, right? So let's do that change. All right, over here, 8, this is 2 elevated to the 3. And all of that elevated to the minus negative x plus 14. All right. To the right, we have 16, which is 2 elevated to the fourth power, and all of that to the x. All right. We have power here. We have, thank you, camera. We have power of a power, and here we have power of a power, which means we can multiply the exponents, and this will be the result. Remember, to multiply the exponents here, this 3 has to multiply the x and also the 14, because in the middle we have an addition. This would also happen if we have a subtraction. So here, 3 times negative x, this is negative 3x. And also here, 3 times 14, this is what, 30, 42? 42, right? On the other side, we have power of a power as well. So we're going to leave the same base, 2, and multiply the 4 with the x. This is just 4x. That's it. From here on, look at that. These two expressions have the same base. So we can cancel the bases and equal the exponents. So we have negative 3x plus 42. And on the other side, we have just the rest of the exponent, 4x. From here and on, this is a regular type of equation, a linear one. All we need to do is move the x's to one side, leave the numbers on another side, and then we find the solution. I'm thinking, let's move this negative 3 over here. That way we'll have a positive x, right? So 42 will be equal to 4x. And again, the negative 3 will pass to add, right? To 3x. It is adding because before it was subtracting. So here I have a 7x, right? 4x plus 3x, that's 7. Beautiful. Over here, the result's still 42. Now, I want to isolate the x, meaning the 7, I'm going to move it to divide, all right? Because it's multiplying. So the result will be 42 over 7. And this is x. Now, how much is 42 over 7? 6, right? Now, as usual, I will write it here in this space, right? Because I try to follow the order. But I don't have enough space. So I'm going to do it here. To the right. And that's it. The number to which we replace x so that the left and the right are the same is 6. All right, guys. Remember, if you have any more doubts. Alba, what? Thank you. What?
Yeah, thank you, Mr.
No, don't worry, brother. You can ask me as many times as you want, all right? And for everybody, remember, I am here to help you. So if you have any difficulties, or maybe you don't know how to do an exercise, or you just want to check if your answer is correct, ask me. I'm here for you.
Profe.
In the meantime, let's stop the video right here.
Profe.
Yes, sir.
Tengo problemas con la 70.
With the 70, all right. You know what? I think we're not gonna cut the video, right? We're gonna do the point 70, and then we'll cut the video. All right, that one. Okay, it's not that hard. Okay, all right, it's not that hard. You're saying that you have difficulties, right? So I'm not gonna do the entire exercise. I'm gonna teach you, or I'm gonna show you just the beginning, right? If you think you can do it yourself from there, then I'll stop. But if you want me to just solve it all, because, you know, you feel like you can't, I will do it, all right? All right, right now you're looking at the book while I copy the question. This is 4 elevated to the x squared. And this is equal to 2 elevated to the x. All right. Camera, please. There. Thank you. Question number 70. As follows. 4 elevated to the x squared. Now, this is a good example of something that is not power of a power. If it were, we would have a parenthesis here. But since we don't, the little 2 is being applied to the x alone, which means the exponent of the 4 is a quadratic one. This is the exponent, x to the x squared, x to the second power, right? This is not power of a power. We haven't done that. We are not going to do that yet. All right? What is it that we know? Well, we want to change the same basis to be the same. The basis to be the same. So the 4, I can move it into a 2 to the second power. That is what I know. That is what I'm going to use. So the trick here is the same, right? We have 2 elevated to the second power, parentheses to denotate power of a power, and all of that elevated to the x squared. All right? To the right, we have 2 elevated to the x. Beautiful. What is the next step? The exact same, right? We are going to do power of a power. Now, the problem is, camera, please, focus. Man, I hate it when that camera doesn't work. Dude, there. All right, the problem is, we need to remember, how do we multiply a number times a variable to the second power? How much is that? This is the result, right? 2 times x squared. How much is that? If I ask you to do this multiplication, how much would you say this is? Anybody?
2x to the second square.
Second power. But yeah, 2x squared. Yes, sir. That's it, right? That's it. Which means now we can solve this thing over here. Remember, we're going to leave the same base, and now we multiply the exponents. 2x squared. On the other side, and for that, I'm just going to erase this real quick. 2 elevated to the x. Beautiful. From here, same trick. Cancel the bases. The bases are now the same, right? 2 and 2, so we can cancel them, which leave us with 2x squared, which was the exponent, and on this other side, we have just x alone. Now, from here, I believe that this is where things got a little bit more complicated for you, right, Marino? From here? All right, so how do you work out this equation? Remember, at the beginning, this was an exponential equation, but now it's not an exponential anymore. We cancel the bases. This is not an exponential. What type of equation? What type of equation is this? This is a quadratic equation, simply because we have a second as an exponent on top of the x. This is a quadratic equation. And for every single quadratic equation, what we usually do is we apply the quadratic formula. So let's try to do that. Let's try to apply the quadratic formula. Remember, the quadratic formula works only if the equation is equal to 0. So let's just move this x to the other side. In here, I have 2x squared. And if I move this one to the other side, I have to move it with the negative, right? Because here is adding, which means it's going to subtract to the other side. Now there's nothing to the right. So I put a 0. And now the quadratic equation is ready so that we can apply the quadratic formula. Did you guys remember that one or not? Let me write it here. Quadratic formula. This is x equals and then a big root. No. a big line, right? This is negative b plus or minus the square root of b squared, right? Minus 4ac, and all of that over 2ac, right? Quadratic formula. Now we can apply the quadratic formula to this quadratic equation. From there, Marino, things should be a lot easier. But I want to do it in another way. I don't have to apply the quadratic formula. Because in this step, we can factorize. And if we factorize this, things are going to be a lot easier than if we do this whole formula. If we factorize, the common factor here will be x. Right? Do you remember how to do
Mister,
common factor,
una
right?
pregunta.
Tell me, Ada. Yes, sir.
Abajo no iba solo 2A.
Yes, sir. All right. So if we do the common factor as x, we have 2x minus 1 and 0 to the right. Okay? Now we have a factor here, right? Factor means multiplication. So we have a multiplication, a factor. What we're going to do is we're going to split this into two possible answers. One answer is x equal to 0. And the other one, the other factor, so 2x minus 1 equal to 0. From the first one, we already know one of the possible solutions. Look, if you were to apply the quadratic formula, one of the solutions will be with plus, and the other solution will be with minus. Addition with one and subtraction with the other one. These are the two possible solutions. One of these will be the solution for the plus, and the other one of these two will be the solution for the minus. I don't know which is which. I'm assuming maybe this one is the minus. I don't know. I don't know. But now we know one of the answers without having to do that equation. How did you find the other solution from here? Simply isolate, right? This is x equals 1/2. And now we have both solutions. So let's take it back. What are the solutions or the values for x that I have to put over here so that everything to the left is the same as everything to the right? There are two solutions. One is 0. 0 to the 2 is 0. So 4 to the 0 is 1. And here is 2 to the 0, so 1 as well. 1 and 1. Okay? And the other one is 1/2. So I'm not going to do it with 1/2 because that's going to take a lot of time. But if you change it, it's going to give you the same. All right, guys. Marino, there you go, brother.
Gracias, profe.
70 for you. No. Thanks to you for asking. Again, remember, if you have any doubts, don't hesitate. Ask me. If in any moment of the explanation there's something you didn't get, tell me and I'll try it another way. All right? I'm here for you. I want to help you guys. Right.
Gus, ¿puedes hacer la 69, por favor?
69. Why are you working backwards? 71, 70, and then 69. All right, let's see. 69. This one. All right. Who was that? Lau Botero?
Sí.
Are you okay? You feeling sick? Are you okay?
Sí.
Okay. A little bit of water. All right. This is 69. Look, I am going to do this one, but only up to this point. Up to the point of the final equation, all right? Because from there, the process will be the same. You'll see that the process is the same. And when we get to that point, I'm going to ask you, what did you think should be the next step? All right? We're going to do 69 together. Give me a couple of seconds, please, and I'll copy the question. All right, 69. The question is 3 elevated to the x cubed, and that is equal to 9 elevated to the x. All right. All right, guys. This is the question number 69. the one we're going to do right now. Again, just like the number 70, recognize that over here we don't have a parenthesis, meaning we don't have power of a power. We don't have a power elevated to another power. No, we don't have that one. What we have is a base of 3, and the exponent happens to be a power. That's it. All right? So what we know is usually the same. The biggest one, and try to make it into the smallest one. So 9 equals, camera please. There. 9 equals 3 to the second power. From here, if we try to rewrite the equation to the right, to the left, sorry, we're going to have the same, right? 3 elevated to the x cube. But in the right, that is what we're going to change. We're going to change the 9, right? So we have 3. I said 3 and wrote down a 2. We have 3 square, all of that elevated to the x. As usual, now we have parentheses, now we have power of a power, so we can multiply the exponents. All right? In the left, we have 3 elevated to the x cubed, exactly the same. On the right, if we multiply the exponents, we have 3 elevated to the x, to the 2x. And just like any other one of these type of exercises, we can cancel now the bases. All right? We are left with the exponents alone. So we have x cubed equal to 2x. Now, at this point and on, we are going to have to do the same process that we did in the previous exercise. I'm going to help you with the first process, with the first step. Change everything to one side so that we can try to split this into possible solutions. In other words, we're going to factorize. And this is where you guys are going to help me. How do we factorize here? How? Anybody? How do we factorize this one? With what?
With x.
X. So you're saying we're going to do common factor, right?
Mm-hmm.
Thank you. Thank you, Lau. All right. So what do we have inside of these parentheses then?
X squared minus 2.
Minus 2. Beautiful. Whatever is left to become the one on top, right? Excellent. From here, we can split this into 2, right? So we have one solution, which is the usual x equals 0. And the other one will be x squared minus 2 equals 0. This looks kind of bad. Let me do it again. X squared minus 2 equals 0. There we go. A little bit better. All right. We have one solution. But everybody can say right now, what type of equation is this one over here? What type of equation is this one?
Quadratic.
Yes, sir. Thank you, Marino. This is a quadratic equation. So we can solve it using the quadratic formula. The one I had over here, I don't have it now. Minus b plus or minus the big root, well, all of that, right? We can solve it using that. Or we can just try to isolate x from here. Since the 2 is subtracting, I'm going to move it to add. Look at this. X squared will be positive 2. Did you see? The negative 2, this one, this number is subtracting, right? So I'm going to move it to add. Positive 2. How do I change this exponent? If I want to get rid of the exponent, how do I move it to the other side?
The square root.
Thank you, Lau. As a square root. So we have x in this one, this side, alone because we don't have nothing else. And on this other side, we have the square root of the value 2. But remember, roots are positive or negative. So we're done. We just got the solutions. These are the other two solutions. In this exercise, just because over here we have a x cubed, we know that we can have a maximum of 3 answers. And there they are. 0, square root of 2, and negative square root of 2. 3 solutions. Looks like we only have 2. It looks like we only have 2. Look at this. Positive or negative. Plus or minus. We have 3 solutions. That's it. Lau, is that better?
Gracias, Gus.
No. Listen, Lau, thanks to you again for asking. Remember, I'm here for you. I'm here to help you. Guys, if we have more questions, let me know. I'll continue with this. But if we don't, it is your time to practice. I'm going to cut the video here and give you all your time to do it. Thank you. Bye-bye.